In this video, we're going to look in a little bit more detail at thermal or heat energy. So heat energy, again, as all forms of energy, it's not a substance, but a form of energy. It's not something that we can see. Heat or thermal energy is the result of the movement of tiny particles in solids, liquids, and gases. So the atoms and molecules in solids, liquids, and gases. The more kinetic energy the particles have, the greater their thermal energy. Okay, so it's not movement that we can see, it's the internal kinetic energy of a substance, the movement of the particles inside it. If we talk about heating an object or a system, it means that we're transferring thermal energy from an object of higher temperature to one of lower temperature. The transfer of thermal energy always happens from the hotter object to the cooler object. So heat transfer is what this topic is mainly about. We're going to talk about different methods of heat transfer. In the little picture there, you can see a cup of coffee cooling down. So the heat energy is being transferred from the coffee, which is hotter, to the surroundings. And in the other picture, you can see the ice cream starting to melt. This time, the surroundings are hotter, so heat energy is transferred from the surroundings to the ice cream as it starts to melt. How does this happen? Heat energy is transferred from an object of high temperature to one of lower temperature by conduction, convection, and radiation. And we're going to talk about each of those three in turn: conduction, then convection, then radiation. Heat is transferred in order to equalize the temperatures of the object and its surroundings, whatever it's in, what environment it's in. So firstly, let's deal with conduction. In a substance, there are particles, and in a solid substance, particles are close together. Those particles are always vibrating, but if the substance gets hotter, the atoms start to vibrate more. If they vibrate more, they bump into or collide with the particles next to them and start them vibrating more. And eventually, energy is passed, kinetic energy is passed from particle to particle along the substance. This method of heat transfer, here you can see in the little animation at the bottom, as the particles move more, they bump into the particles next to them, and as you can see the red color moving across, you can see conduction happens from where the source of the heat is, near the Bunsen burner flame, along the solid until it reaches the end. It's important to remember that conduction happens mostly in solids, that metals are the best conductors. Other substances such as wood, glass, plastic are not good conductors. We call them insulators. But they can conduct to a certain extent. Solids are much better than liquids and gases because their particles are close together. They conduct heat better. If a substance doesn't conduct heat, it's called an insulator. So substances are either conductors or insulators. In this little animation of a frying pan, the metal of the frying pan is a good conductor, and the wood of the handle is an insulator. It is not good at conducting heat, which is what we want for the handle of a pan, because we don't want to burn our hand. So best conductors, metals; poor conductors, glass, plastic, wood, and gases and liquids are poor conductors or insulators. The next method of heat energy transfer we're going to deal with is convection. Now, convection is the movement of thermal energy by the mass movement of particles in a liquid or gas. So that phrase, mass movement of particles, means there are lots of particles that are actually moving about. So different from conduction in a solid, where the particles did not move about, they just vibrated more. Now, liquids and gases, the particles are able to move, and they move about, transferring kinetic energy and therefore heat energy. So as a liquid or gas is heated, the particles gain kinetic energy and begin to move more. If they move more, they will spread out because they bump into each other, and the fluid becomes less dense. Remember, density is the number of particles compacted into a space. So they become less dense, they move further apart. This hot, less dense fluid then begins to rise above the colder fluid, which is more dense. So when the hot fluid rises, the colder fluid then is forced downwards to replace that hot fluid, forming what's called a convection current. And it's like a cycle that continuously heats water or whatever substance. There you can see these arrows indicating convection. At the bottom, the Bunsen burner flame heats the liquid. The particles move more, become less dense, and rise to the top of the pan. As they rise, they start to cool, become more dense, and then they sink. And you can see the arrows on the outside of these circles are blue as the particles are getting cooler, and in the center where they're being heated, they're red to indicate the particles are hot and rising. Convection cannot happen in solids because the particles cannot move. It can only happen in liquids and gases. And there you see a convection oven. Sometimes we use convection as a method of heating. Inside the oven, you feel the air moves about and transfers the heat throughout the oven. You may have felt this if you've ever put your hand over a candle flame or maybe over a fire. You can feel the hot air rising. That's part of a convection current. The next method of heat energy transfer is radiation. Now, radiation is slightly different because it's the transfer of thermal energy by infrared waves. And although radiation can take place through substances, through solids, liquids, and gases, it can also take place through a vacuum. So all objects emit and absorb radiation. The higher the temperature, the more they emit. So your coffee cup sitting on the table next to you is emitting thermal energy by radiation to the surroundings. It's radiating heat and the surroundings are heating up slightly. When objects absorb this energy, their temperature increases. So as you go outside on a winter's day and stand in the sun, you are absorbing the sun's radiation. That is energy that's traveled in waves all the way from the sun through the vacuum of space. And there you see the sun radiating these waves that are hitting the Earth's surface, and you can see the atmosphere becoming red and therefore heating up. You can see the heating occurring. Radiation will travel through a vacuum. It does not need a medium or material to pass through. No particles necessary. But please remember that it can also pass through solids, liquids, and gases. There you go. There's our microwave heating our food. There's some thermal radiation taking place, and when you take your cup of coffee out of the microwave or you pour it from the kettle, you certainly can feel the warmth radiating from your food. Lastly, we need to deal with different surfaces and radiation, how different surfaces are affected, or absorb or emit or reflect radiation. So certain surfaces are better at absorbing thermal radiation than others. Dark, matte surfaces, matte means not shiny, are good absorbers and emitters of infrared radiation. Light and shiny surfaces are poor absorbers and poor emitters of radiation. And light, shiny surfaces reflect, but dark, black surfaces, matte surfaces, do not reflect very well. So there's a little graphic just showing you the difference between emitters and absorbers. And obviously at the end, the white and silver are good reflectors. And there's different uses for these. We'll do some work on this soon. I hope that has helped you understand thermal energy transfer.